Let me tell you about the most embarrassing bug I've shipped. No crash, no 500 error, no broken API response. Just a button pushed 4 pixels to the left on mobile. Playwright's functional tests passed. The API returned 200. The staging QA pass looked fine. Nobody was checking the layout at exactly 375px viewport width. It went live. A week later, someone noticed the conversion drop, 4 pixels, 1 week, conversion impact. That incident changed how I think about test coverage permanently. Because here's the thing, assertion-based tests can't catch this. Today I'm going to show you the Playwright visual testing setup that would have caught that regression. Architecture, code, and CI-ready workflows. Playwright ships with a built-in screenshot assertion called toHaveScreenshot, not a third-party plugin, built right into the framework. On the first run, Playwright generates a baseline screenshot and writes it to a snapshots directory next to your test file. On every subsequent run, it compares the current screenshot against that baseline. If it exceeds your threshold, the test fails. And when it fails, Playwright writes 3 files, the expected screenshot, the actual, and a diff image highlighting changes in red. That diff image is what makes this useful. You're looking at a picture of what broke. A reviewer can glance at it and know exactly what happened. Visual testing in Playwright works in 3 layers. Layer 1, baseline generation. This commit history becomes a visual changelog. Layer 2, comparison on every run. Pixel diff against baseline, configurable threshold, and masking for dynamic content. Layer 3, CI integration. Visual tests run after functional tests pass. Failures surface diff images as PR artifacts for human review. Now let's look at exactly how you build each layer, starting with the basic setup and imports. Here are the imports. Minimal. Page is your browser object and expect is the standard assertion module you already know. We navigate using standard commands. Wait for load state network idle is critical to avoid mid-load screenshots. The toHaveScreenshot assertion captures the entire page when full page is true. The threshold is a 2% pixel tolerance for anti-aliasing. Max diff pixels is a hard cap to catch those small but dramatic element shifts like our 4-pixel problem. For design systems, use component level isolation. Instead of the whole page, we assert on a specific locator to clip the screenshot perfectly. The threshold here is tighter, just 1%. This pattern would have caught that CTA regression the moment the margin change landed in a PR. High sensitivity, isolated test. Dynamic content will cause false failures. The mask parameter fills those regions with a solid color before the diff, excluding them from comparison. Rule of thumb: if a region can change between runs without a developer touching code, mask it. Everything else should be stable. When you intentionally change the UI, you regenerate baselines with one command, pytest update-snapshots. This updates the PNG files in your repo. This builds a visual changelog in Git, but one rule: never automate baseline updates in CI. That's how regressions get silently blessed. Human commits only. Finally, configure global defaults. Disabling animations ensures every screenshot is in a settled state. We also hide the text cursor carré to avoid flakiness. 3 mistakes: testing against live environments, having too much surface area, and not masking dynamic content. These are the biggest sources of noise. The solution to rendering drift is running visual tests in the same Docker image you use in CI. Playwright's official images give you that consistency. Visual tests run as a separate stage. Failures block the pipeline and surface diffs as artifacts. It keeps the review loop lightweight but safe. toHaveScreenshot is stable, but thresholds need calibration. Baseline management overhead is real, but it's a manageable cost for the safety it provides. Finally, visual testing catches regressions, not bad design. Human eyes still matter for whether a technically correct change is actually right. A single UI regression costs more than 6 months of maintenance. The full code is in the description. See you in the next one at Automate and Elevate.